You gotta abide by what I say. And if you don't, better know. All right, so we're gonna make a slight change with this syllabus. Let's do this. Place. Okay, telling you right now, I'm making a change. I'm gonna upload it later. I'm gonna shift this. 7. Do a cut. I'm gonna shift this. Project. And I'm gonna do an insert. Insert below. This in here. Paste. Paste. Oops. Oops. Project. Is that it? Okay. All right. So I'll take this. I'll take this because I know somebody's gonna say something. Get me in trouble. That's what y'all do. Paste. Alright. Project 1 required exercise, build a cable chart capstone. I just moved that. Do y'all see this?
Yes, sir.
When is it due? 11/16, right? But don't worry, we're gonna do it all together. We're gonna do it together as a class. But I'm moving this. But look what I'm moving now. I'm gonna move this. Stay with me. I'm gonna do a cut. I'm gonna do a copy. I'm gonna do a cut. I'm copying. Cut. Where is it? 6. I messed up now. I don't know what I did. Oops. Troubleshooting is what we're doing today. Right here. Sunday. Come on in. Morning. Strolling in here. What's happening? You ready to learn something today?
Yeah.
No, you don't. You don't learn that. Copy. I'm gonna do this. Paste. Okay. Done. And then I'm going to do this. Take this out. I'm going to do delete cell. Delete entire row. Say yes. All right, there it is. Okay, here's the change. Control S. Control save. Here's the change right here. Next week, I'm gonna put this in red because I know y'all gonna come up in here late next week. You're gonna come in here late. You'll be like, I didn't know. So here we are. This is us today. We're gonna do troubleshooting of PC. We're gonna do that today. That is, you got a lab, a BIOS, UEFI lab. We'll do together. We're gonna talk about a couple of things like the BIOS, UEFI. I see 2 labs on here. One here. One here, we'll do that in class. You got a quiz you gotta do, right? Seems like you got a quiz every other week. You gotta do a quiz. This is next week. This is next week. I just moved it. It was down here. No, Thanksgiving. What did I just do? What's happening next week? Should you be here?
Yes.
If you don't be here, then you got to do it on your own. I'm not going to do this hands-on project. We are going to do a hands-on project next week, 8:30. You walk in here, you're going to see computers on that desk. You are going to do a project, a hands-on project. I'm making a change. If you don't like it, I don't care. We're going to do a hands-on project. I want you to touch the computers. You got a project, we're gonna do it together. You can break up into teams, you can do solo. I'll do my best on creating some equipment in the back. And you have to demonstrate to me that you know how to take some stuff out and put it back in. Is that hard? If you don't know how to do it, but that's okay. That's why we learn it. Huh? Now, you stay with me and I can get you through this. I'm not supposed to do this, but I'm going to do it. Now, I'm going to show you something. I'm going to scroll down. Now, this is how it's set up in Blackboard. The final project is way down here. Look at the date. 11/23/2025. Now watch this. I'm going to go in here. Look at this. These are y'all's choices. I didn't come up with this. Y'all got to listen to me. I didn't come up with these choices. Back before we got a new program director and a new direction, I had I was a free-for-all. Right now they're narrowing me down. I got no choice. I'm going to make this change because I don't think you should leave this building, go look for a job if you ain't touched a computer and did a project. Everything else after this class is up here. I need you to touch the computer, show me that you know how to go over the computer, open it up, take some stuff out. Mr. Darrell, I took out the main stuff. Then I'm going to say, put it back. You're going to put it back, and I'm going to do it. You're going to come up here, you're going to sign your name. Now, nobody else in the other class is doing this. Not that I know of. Here are your choices. Y'all ready for this? Project 1, boot process walkthrough. That's one. This is your project. 10% of the grade. That's one choice. See that choice? Read it. Here's your second choice. Read it. Here's your third choice. Read it. Here's your fourth choice. Read it. Here's your fifth choice. That's it. All of that is on your own. Now you got a choice. Here's what you're gonna do. If you come in here next week and do my project, there's gonna be something that's gonna be up here. It's gonna be called, I ain't put it in there, it's gonna be called Project 6, hands-on. If you come up in here next week, guess what you chose? Hands-on. You don't have to choose 5, 4, 3, 2, or 1. You're gonna love it. Now, some of your classmates ain't listening right now. So, after I do the project next week, they gotta do either 1, 2, 3, 4, 5. The number 6 that's not showing ain't gonna be available, because I ain't gonna do it. You had your one shot. It's called one and done. You don't show up next week to do my hands-on, too bad. You gotta choose one of these. Oh, have you read yet what you gotta do on these? Oh, it's deep. You gotta do PowerPoint slides, and you gotta do 3-point pages. Now I'm gonna do this. We're gonna do the demo. We're gonna do hands-on. We're gonna take our time, the whole 2.5 hours. We're gonna, some of y'all, we'll leave early once you do my hands-on project. What I need you to do after that is write me a paper or do a PowerPoint slide or something like that, 3 or 4 page PowerPoint slide, telling me something about what you got out of the exercise. 10%. You're done. That's your project. I gotta do something, because when you go in there and she sees it, when they see it, I'm like, well, what did you do? You didn't follow this rubric. I'm like, well, I came up with something else. They did send me some kind of paper or something saying, this is what I got out of the project. That's not hard. Is that not hard? So now, make sure I understand this now. I'll try to do it by tonight. By tonight, there's going to be a number 6 down here. I'm going to add it in. We're going to come in next week. Oh yeah, by the way, bring in a Phillips head screwdriver. Can you remember that? If you don't, I got one. I got 2 or 3 of them, but every time I do the project, we run out of Phillips heads. We have to wait till somebody else finish. We had to borrow their Phillips head. So if you can remember, just bring a little Phillips head screwdriver. We okay? That's all I'm asking you to do. Bring in a Phillips head. If you forget, then you just got to use somebody else. Okay? We're going to come in, and I think I have enough piece of equipment. If not, we'll just have to pair up or something like that. We're going to do my hands-on, and that's it.
The project one is on October.
You said next week bring in the screwdriver and we'll do this?
Yeah.
Okay.
Bring the screwdriver. So let me upload this right now, because I already know I'm gonna catch hell on this. I already know, but it is what it is. Okay. Okay, 8:40.
Project's next week.
Yep, sure is.
On lesson 5.
All right, stand by.
Next Tuesday. I mean
No,
next.
Wednesday.
Yeah, that's what I meant to say. Next
Yeah.
Wednesday.
Next Wednesday. Hold on, upload this right now, making a change to the schedule. Okay, 8:41. You need to listen to me. I'm about to close that door at 8. Let's do this. You need to be here at 8:40. You're not here at 8:40, the door is locked. Keep walking. Just keep walking.
We understand, sir.
I can't have y'all coming in at 9 o'clock, 9:30. You walking up in here, I need to do the project. This door is gonna be locked. I'm gonna lock this sucker. If the door is locked, just keep moving. That means you holding me up. You got a project next week. If you choose this project, show up. Show up. Show up. If you don't show up, then you got the other project to do. And heaven help you. That's all I gotta say. I'm trying to help you. First of all, I'm trying to help you learn something. Second of all, I'm trying to save you some time. Because come Thanksgiving time, you ain't gonna wanna do no project. Gonna take you 4 days. If you want an 8. Why do I do this? Why?
The project one is due on October 5th, Sunday.
No comment. What I'm gonna do is this. I'm gonna upload this. You know what? I can see it now. I can see the email's gonna be flying. Mr. Dale, we have students that are complaining about the project. Critical thinking, lack thereof. Critical thinking. Y'all know what critical thinking skills are? Something that you gotta have in this field, or you ain't gonna get a job. Go to automotive. Critical thinking skills. Okay, I'm getting ready to do this. I'm gonna upload this modification. Put a date on this. Stand by. Put a date on this. Rename. Name, man. What's the rename? Okay, I'm putting a date on this. The date is 09.24.2025. All right. Again. Go ahead and open it. Yep. Save. Again. Okay. Here's the change. Let's say this again. Here's the change right here. It's in red. I'm getting ready to upload this into the schedule. And I have the right to make modifications of the schedule. Next week is the final project. Right now, there are 5 projects. I'm going to add a 6th project. The 6th project is hands-on. The other 5 are not. What did I just say?
6 projects, hands on, the other 5 are not.
That means that it's on you. It's up to you to write a 9-page paper or PowerPoint slide and an audio video. If you do my project next week, only thing I'm gonna ask you to do is that project and maybe write me a page and a half or something saying what you got out of the project. That's it. 10% of the grade, done. Okay. So what I'm asking you to do is, why don't you behave and show up next week. Why don't you just do, I tell you what, why don't you just show up next week? And I'll do the rest. How about that? Okay. So I'm gonna make this change now. Get in trouble. I'm gonna get in trouble. I'm going to get in trouble.
Just tell them one of us learned how to do it on your computer. Just tell them one of us learned how to do it on your computer.
You did, you tell me.
Yeah, I got you.
Change this, edit content. Okay, I'm going to delete this. Edit file. I need to do this. I'm gonna delete it, I just deleted it, now I'm going to add it back. I'm gonna do a plus, content. I'm gonna go find the content. I'm going to do cloud. OneDrive, stand by. I want to get this done, so it's going to take a little time. It's now 8:46. I'm going to go to CIST 1122. Scroll down. Syllabus, there it is. Select, there it is. Import. That it? Let's do view only. I'm going to do view only because I know some of y'all take a copy of it and send it to the dean, so that's y'all's mentality. Okay, saved. Okay, we good to go? Let's see, let's check it out. All right, here we go. Is it there?
It is now.
Bam! There it is. You see it? This is next week. How do you make this thing bigger? This?
You could,
Yeah, that's it, right? Okay, let's do this now. Are you gonna show up next week? Are you gonna be on time?
yes, sir.
Can you possibly bring a screwdriver? What kind?
Phillips
We good?
Yes, sir.
All right.
What if we don't bring a screwdriver?
Then you gotta use somebody else.
I have like 4 Phillips heads in my
I did.
car.
Then bring them.
Me too.
Bring them. Bring them. Bring them, man. Bring them.
I'll bring all of them.
There you go. Okay, y'all. So now let's do the assignment. We got troubleshooting today?
Yes, sir.
Yeah, let's do troubleshooting. So let's go ahead and open this up. Make it visible. Okay, so what kind of videos we got today? We're gonna talk about peripherals. This one's easy. The PCI. We're gonna talk about PCI. This guy's pretty cool. BIOS, UEFI. That's, man, what? Mr. D, only 4 videos? 1, 2, 3, and 4 videos. And then we do some lab. Can we leave?
Yeah.
Okay. All right. I know I've been doing this every time I walk up in here. You tell me what to do. You know what I'm getting ready to do, right?
Yeah.
Y'all getting tired of this? I am. What is this?
Motherboard.
Okay. What's next? CPU?
Yes,
What's over here?
sir.
Okay. RAM? 2 sticks?
Yes, sir.
Okay. What's next? We're gonna do storage?
Yes, sir.
Okay. Got storage. We cooking. We'll just say storage. All right. What's inside the storage? What's the technology inside the storage?
Magnetic.
Magnetic.
Solid state.
Solid state.
Hardware.
Okay. So what about the interface? Can we talk about the interface? Okay, let's start with the first one. Old school. PATA. P-A-T-A. It's a ribbon cable, right? What's the second one? Start with the S. SCSI.
What's the one on top? Magnetic?
Magnetic. Magnetic. This is the technology inside the drive. We call it technology inside. Inside storage. Okay? Inside the storage, either magnetic or solid state. The interface, remember the interface is right here. The interface connects to the motherboard. You can have PATA. That's a ribbon. You know that ribbon cable? SCSI is a ribbon cable, but it has a lot of connectors on it because you're going to connect a bunch of drives to it. Okay. Then the third one is, look at your notes, SATA, S-A-T-A. The fourth one is NVMe, or better yet, M.2. Remember I told you that? what I really love, the little small chip. You put it on the motherboard, you screw it in, that's a hard drive. Okay, so these are interface. Okay, cool. Processor.
What's the word on top underneath interface?
On top of the interface. Where?
The one underneath.
Here?
Yes.
PATA.
PATA.
Yeah, this should be in your notes. Should be in your notes, right? How do y'all take notes? Oh yeah, you don't. Use this? That's how y'all do it? You ain't ready for that. You're not AI yet. So you gotta write some notes down, either on some paper or your phone. That's what I do now. I start writing stuff on my phone.
Is that SATA underneath SCSI?
What does your notes say?
SATA.
What do your notes say? SATA, right?
Yes.
How many times have we done this? What day is this? 5th or 6th?
6th week, sir.
This is our 6th-time meeting?
Yes, sir.
6?
Yes, sir.
Is that NVMe?
Yes.
Awesome.
NVMe. NVMe. Non-volatile memory something. Okay. Storage, processor, memory. What else do we have? Oh, a Go Juice? Another short description for power supply is PSU. Power supply unit. What does it connect to get power? Plug. Okay. So, North Bridge, South Bridge. Let's do the first one. North Bridge. I guess we can. North Bridge, South Bridge. North Bridge, South Bridge. This is awful. Almost. North Bridge, South Bridge. Right? And we've got, what do we call these little lines that are on the motherboard? I'm waiting.
Line.
What is that? Bus line. Bus line. Is it data line, bus line? Bus or data? Data lines? I prefer bus lines. Little lines. Remember that? You look on the motherboard, you see the line. You turn the board over, you see a bunch of little lines. How do you think the ones and zeros are going to move around from memory to processor to storage to the lines, right? On the motherboard. It's called the bus line. Okay? Okay. So we got the bus lines. What else? Fill it in. What else we got?
GPU.
Okay. You want to do that? GPU? Graphics processor unit? We'll say GPU. You need to tell your classmate about next week. This is the monitor. Monitor. And then here's a keyboard. And the keyboard probably uses a USB, right? Want to do that? USB? And this is probably HDMI. HDMI, you want to go with that? Okay. You know, how about a rack? Yeah. What are we going to do with that? USB?
Yes, sir.
Okay. What do you think? We're almost there. Okay, we got some more of these little, we call them PCI slots, right? PCI slots. Alright, here. We got some little bitty ones too. Let's do this. That's 8. 1, 2, 6, 8, 16. Anyway, they come in different flavors. They call it PCIe. PCIe. Right, let's see. We're missing some. Oh. This needs power, right? Take one of these cables. Put it in here, power. Who else needs power? Okay, you wanna do that? CPU has to have power. I'm gonna go this way. The cables are right here. On this. Yes, sir. That's what I was waiting on. Good man. All right. Processor has power, and of course we got that big fat cable right here, 24 pin. Goes here, right? I think we might be ready.
There's one of those.
Oh, good man. Right here? Yeah. Man, I forgot about that cat. Right? Last thing that's missing. Now, we talked about it, but we didn't talk about it a lot. When you turn this thing on, this board with all of these devices goes through what's called a power on self-test. It's called a POST. Power on self-test. All that is to check to just make sure stuff is in there and it's functional. Power on self-test. There is a chip, a special kind of chip. Let's do it in red. Special kind of chip that sits here, somewhere on this board. It's called a, say it again? Huh?
TPO.
No, sir. It's a part of, that's a part of, nope. You have heard of it. BIOS, UEFI, the TPM chip might be sitting right over here somewhere. TPM chip, security. We'll learn about that later. There's another chip, all kinds of chips on this board, but the TPM chip has to deal with encryption and stuff like that. Sometimes it's embedded in the BIOS UEFI. Sometimes the TPM is on the processor. Yes, sir.
What's next to the BIOS / the U word?
Say what? Say it again, brother.
What's next to BIOS by the slash?
UEFI. UEFI.
UEFI.
UEF. And this is what we're getting ready to talk about now. Are you with me?
Yes, sir.
So what I've done is I've walked you each week. Remember the first week, we talked about the mother. Then we talked about all kinds of stuff. Each week, I've added stuff in. You gotta know this. You need to know this. If you want to do well in this field, this is your equipment. If you work on cars, what kind of equipment do you use? You work on cars. What's your equipment? Your tools for a car, right? A jack, a wrench. Those your tools? You're a mechanic for a plane. What tools do you use? Whatever plane tools are. There you go. If you fly a plane, what is your tool?
Instrument.
The plane. Okay? You in IT. Come on now. This ain't rocket science. You're in IT. IT can be cyber, gaming, programming. What is your tool? Is that not your tool? Oh, you just in the air doing this? This is your tool. Now, you may not be able to actually walk into the data center and touch it, but that's your tool. Really, your tool is this. 1, 2, 3. That's your tool. You may not even see it, but this might be on the floor. Hey, this is your tool right here. That's your tool. This is your tool. And the first thing you need to know about this tool is, how does it work? Once you know how does it work, then you're like, it's in the back of your mind now. I know how it works because I took a class with Mr. D. He told me about the motherboard. He told me about the processor. You see where I'm going with this? He even told me about a monitor. You see the monitor? Watch. That's a monitor. Where's the mouse and the keyboard? Watch this. Mouse and keyboard? Come on, y'all. This is your tool. We've done it all. Now let's go to this tab. Enough yapping, as my daughter would say. Papa, you just yapping. Let's talk about this cat right here. Okay? Well, actually, let's talk about the PCU. Let's do that. Go, go, go. Go, go, go.
Say you just bought a new computer, and with excitement, you unpack it and set it all up.
Right.
The first thing you want to do is print out some photographs of the last family party, so it's time to head back to the store to buy a printer. A printer is known as a peripheral device. A computer peripheral is a device that is connected to a computer but is not part of the core computer architecture. The core elements of a computer are the central processing unit, power supply, motherboard, and the computer case that contains those three components. Technically speaking, everything else is considered a peripheral device. However, this is a somewhat narrow view since various other elements are required for a computer to actually function, such as a hard drive and random access memory, or RAM. Most people use the term peripheral more loosely to refer to a device external to the computer case. You connect the device to the computer to expand the functionality of the system. For example, consider a printer. Once the printer is connected to a computer, you can print out documents. Another way to look at peripheral devices is that they are dependent on the computer system. For example, most printers can't do much on their own, and they only become functional when connected to the computer system. There are many different peripheral devices, but they fall into three general categories.
What are they?
Input devices, such as a mouse and a keyboard. Output devices, such as a monitor and a printer. And storage devices, such as a hard drive or flash drive. Some devices fall into more than one category. Consider a CD-ROM drive. You can use it to read data or music, input, and you can use it to write data to a CD, output. Peripheral devices can be external or internal. For example, a printer is an external device that you connect using a cable, while an optical disk drive is typically located inside the computer case. Internal peripheral devices are also referred to as integrated peripherals. When most people refer to peripherals, they typically mean external ones. The concept of what exactly is peripheral is therefore somewhat fluid. For a desktop computer, a keyboard and a monitor are considered peripherals. You can easily connect and disconnect them and replace them if needed. For a laptop computer, these components are built into the computer system and can't be easily removed. The term peripheral also does not mean it is not essential for the function of the computer. Some devices, such as a printer, can be disconnected and the computer will keep on working just fine. However, remove the monitor of a desktop computer and it becomes pretty much useless. Here you can see a typical desktop computer system with a number of common peripheral devices. The central processing unit, number 2, motherboard, number 8, and power supply are the core computer system. Expansion slots, number 4, on the motherboard make it possible to connect internal peripherals, such as a video card or a sound card, not shown. Other internal peripherals shown are a hard disk drive, number 7, and an optical disk drive, number 6. External input peripherals are a scanner, number 1, display monitor, number 10, keyboard, number 13, and mouse, number 14. External output peripherals are a set of speakers, number 9, and a printer, number 16.
Okay.
Note that labels 11 and 12 in the figure refer to software and are not peripherals.
Ooh.
There are many other examples of peripherals, such as a microphone, web camera, headphones, external hard drive, and flash drive.
Okay.
Most computer users have at least several of these peripheral devices. Internal peripherals are directly connected to the motherboard, using one of the different types of slots on the motherboard. External devices can be connected using a wired connection or a wireless connection.
Okay.
As the name suggests, a wired connection uses a cable that needs to be plugged into the computer using a connector. The most widely used connector is a universal serial bus, or USB connection,
Okay.
but several other types are used, depending on the specific computer system and the type of peripheral. A wireless connection does not require a cable. The most widely used wireless connections are Bluetooth and Wi-Fi.
Okay.
Bluetooth is good for very short distances, so peripherals such as wireless mouse and keyboard typically use a Bluetooth connection. Wi-Fi is good for longer distances. If you have set up a wireless network in your home or office, you may be able to print wirelessly to a printer if it is also connected to the network.
Okay. We finished? Nope.
Computer peripherals expand the functionality of your computer. Some are essential for the computer to properly function, such as a monitor and a keyboard. Others serve a more specialized purpose, but allow you to do a lot more with your computer.
Right. I got one of those. Okay, so the word peripheral is all over the place. I wanted to do that for you because it's all over the place. Okay, so keep forgetting this, and I apologize. But there's one more interface for this storage. It's like common sense, but I keep forgetting it. I'm gonna put it in blue. Y'all ready for this? USB. Can I have a storage that has USB? I do it every day. What's that? USB? That's an interface. What's inside the drive? Solid state. Is that magnetic in this drive? No. It's probably solid state. It's solid state. Solid state is the technology inside. This is a drive. This is a drive. Solid state is the technology inside the drive. The interface is USB. One more again. This is storage. Do we all agree that this is storage?
Yes, sir.
I'm telling you right now, it's 128 gigabytes. At the time, it cost me like $15 at Walmart. You see it? Storage. Solid state. Interface. Okay. And I keep forgetting it because I just forget because I'm old. Okay. Number 2. What is he doing? PCI. I like this guy. I don't like this.
People can get crazy trying to stop a cyber attack.
I don't have to listen. Now I have to listen. Stop. Now I can listen. Okay. All right. He's pretty cool, actually. I think he talks fast, though, like me. Go.
I get a lot of questions about PCI Express. What works with what doesn't work with what are the different generations? What does it all mean? So today we're going to tell you everything you need to know about PCI Express 3.0 as fast as possible. So let's start with the very basics. PCI Express is the interface that is used to plug modern expansion cards into modern computers or motherboards. It completely replaced PCI and AGP, which is great because AGP was only for graphics cards and PCI had to be used for pretty much everything else. PCI Express works with pretty much anything. Sound cards, network cards, RAID cards, video cards, they'll all pretty much fit as long as you're aware of a few simple guidelines. Now I said they're universal, but PCI Express slots are available in a variety of different physical configurations. The most common ones are 1x, 4x, 8x, and 16x. All of these types have different slots on the cards themselves and different slots on the motherboard. The cool part about that is that they're upwards and downwards compatible though. Here I am plugging a PCI Express 1X card into a 16X slot. It gets the same power delivery, it just gets less bandwidth delivered to it because that's all a sound card actually needs. And not only that, but I can take this PCIe 8X RAID card and plug it into a PCIe 4X slot. It'll still work, but it will only have half of the bandwidth available to it that it would have otherwise had if you plugged it into an 8X slot. The other thing that affects the performance of PCI Express is the generation. Here I'm holding a PCI Express Generation 2 16X card, and here I'm holding a PCI Express Generation 3 16X card. They look physically the same on the connectors, but the actual available bandwidth has doubled. In fact, the available bandwidth of PCI Express cards has doubled with each generation. So a PCI Express Generation 1 16X slot is only equivalent in performance to a PCI Express Generation 3 4X slot. So the takeaways from this are pretty straightforward. PCI Express cards work in PCI Express slots as long as there's nothing physically in the way. Performance, on the other hand, is going to be dictated by what generation of PCI Express the card and the slot are running at. So it'll run at whatever is the lowest generation of either of the two components. So Gen 2 card, Gen 3 slot, plug them together, they run at Gen 2. And then performance is also determined by the length of the card and the length of the slot. So for example, this quad port gigabit NIC needs at least 500 megabytes per second of bandwidth in order to operate at peak efficiency. That means if I have an older PCIe Gen 1 motherboard, I'll need at least a 4x slot or a hypothetical 2x slot to get the bandwidth I need, because it's only 250 megabytes per second in a 1x slot. However, if I have a PCI Express Gen 2 motherboard, I could even use a 1x slot to get everything I need, because that'll be about 500 megabytes per second. Thanks for checking out this episode of Fast as Possible. Make sure you subscribe to TechQuickie and also like...
Shut up. Okay. All right, 2 more to go. So, PCI, I'm gonna run over this right quick. PCI allows us to put in these expansion cards. And that's why I drew it like this. Here's a motherboard and the slots over here. Could be over here, depends on the board. But I put them over here. So now he said that was a PCI. There are a bunch of PCIs, right? The main ones are, what did he say, 2X? 2X, 4X, 8, and 16. Trust me, there's one called a 1X, and there's one called a 6X. So why don't we make this one 2X? Make this one a 4X, 8X, and then maybe 16, 2 16s. The graphics processing cards today, not 5-10 years ago. Graphics processing cards today, we run PCI E16X. In the old days, they used to have something that was called AGP. That's old school. Okay? What do you say to that? We get the PCI thing? It's just the cards. So next week, I think a couple of the computers has a card in it. I don't know what it is. Probably just regular PCI, old school. You're gonna check it out. It's like, look at it. Oh, so that's a PCI. You're gonna actually feel it. You're gonna feel it. Right? You're gonna touch it. I'm gonna ask you to put it back in. And I'm gonna check it to see if it's seated properly. If it's not seated properly, you gotta do it again. All right, so that's PCI. We did that, right? So we're almost close to finishing this motherboard. PCI slots, processor, memory, Go Juice, storage. What's missing? Oh, North Bridge, South Bridge. In the newer boards, the North Bridge goes away. It's a part of the processor and the memory and the graphics processor. North Bridge goes away. And we only have this thing down here. It's called the South Bridge. But I like to talk to you about the North Bridge and South Bridge because of history. So you know it in your mind. So you can talk intelligent because you're gonna get, when that tech you on the news 2 days ago. Yes, sir. Okay. Now we're ready to talk about this cat right here. It's kind of like it's sort of like this guy. This is like your brain. This is a second brain. Okay? Like a second brain. Because it's gonna do, the first thing it's gonna do is what's called a power on self-test. POS. Power on self-test. Check the equipment. All of these components, just to see if they function. Like if the memory is not put in properly, what will happen is this chip will say, wait a minute, there's a problem with the memory. It'll probably give you a couple of beeps. And the computer will not boot up. Will not go up into Windows or Apple, for that matter. So that means that this guy's in charge of just checking to make sure the equipment is functional. That's all it does. Lower level, just function. Is it there? Can I get some ones and zeros to it? Okay, fine. After that, it's up to your operating system to do the rest. There's some other things that this does too. So why don't we ask this professor, what are some of the other things that we get in BIOS UEFI? Pay attention. Then we'll do this one, and that will be it for the videos.
What is the BIOS, CMOS, and UEFI?
I don't know.
So that's what we're going to talk about in this video. Now, BIOS stands for Basic Input Output System. The BIOS is firmware that's built into the motherboard that initializes the computer's hardware as the computer is being booted. And then after it initializes the hardware, it then searches for a boot device such as an optical drive or a storage drive to boot software such as an operating system. So from the start, when you first turn on the computer does what's called a power on self-test or POST, which is run by the BIOS. It tests the computer to make sure all the requirements are met and if the hardware is working correctly before starting the operating system. If the computer passes the test, the internal speaker will make a short single beep, which indicates that the computer has passed the test and is booting up normally. However, if there are no beeps or multiple beeps, then that means that the computer has failed the test and something is wrong. And the computer needs further troubleshooting to find out what the problem is. So whether there are no beeps or multiple beeps, the computer will generate a beep code to help you pinpoint the problem. So for example, if the computer generates 3 long beeps, then that could indicate a keyboard error. Or if the computer generates a continuous short beep, then that could indicate a problem with a RAM module. So whatever BIOS is installed on the computer's motherboard, you can always refer to the manufacturer's documentation to find a list of beep codes and what they mean, so you can pinpoint the problem and correct it. The BIOS software is stored on the BIOS chip on the motherboard. The BIOS chip is non-volatile, which means that the contents of the chip are retained even after the power is turned off. But even after the computer is turned off, the computer does need to maintain certain settings, such as the date and time, the boot sequence, and certain hardware settings. In other words, the custom settings that you have configured in the BIOS. And these settings are stored on the motherboard in a special chip called a CMOS chip. But unlike the BIOS chip, which is non-volatile, the CMOS chip is volatile, meaning that it needs constant power to maintain its contents or settings. So in order for the CMOS to maintain its settings while the computer is turned off, it uses a battery. And this battery is called the CMOS battery. The CMOS battery is a small button cell battery which can be seen on the surface of the motherboard, and it's usually located on the bottom right-hand corner. And it's basically the same type of battery that is typically used in wristwatches. Now, as I stated before, the CMOS...
Let me say this to you. Some of the newer boards are so modular because of the alien technology and dope smoking. This is the south bridge in this board. The north bridge is, you don't even see it because it's integrated into the processor and RAM area. You don't even see it. And some of the newer boards, that's what these newer boards do. Smaller boards, they will take this, and put it in the south bridge. Just for the giggles. That's dope smoking and alien technology.
CMOS needs constant power that is supplied by the battery. But if the battery is removed and then reattached, the BIOS will reset back to its default settings from the manufacturer and erase any custom settings that you have configured. Now, a lot of people get confused about what's the difference between the BIOS and CMOS. And these terms are often used to refer to the same thing, but they are different. So just to clarify things, the BIOS is the actual firmware or program that comes with your motherboard. And that firmware is stored in the BIOS chip. But the settings that you actually make to the BIOS, such as the date and time, the boot sequence, fan speeds, and things like that, those settings are retained in the CMOS chip. Now, the CMOS chip is not necessarily its own chip. On modern motherboards, it's been integrated with the real-time clock that's part of the Southbridge chipset. Now, a new type of BIOS is called UEFI. UEFI stands for Unified Extensible Firmware Interface. Now, most, if not all, new motherboards are shipped with this newer type of BIOS. UEFI has several advantages over the old BIOS. And the first and most obvious, just by looking at it, is that it has a user-friendly graphical user interface that supports different colors and even animations. Whereas the old BIOS has your typical blue screen that resembles the Windows blue screen of death. UEFI can also recognize larger storage drives, and you can even use a mouse in the UEFI interface, whereas compared to the old BIOS, where mouse support wasn't even available and you had to use your keyboard only. And UEFI also has a built-in feature called Secure Boot. And Secure Boot stops any digitally unsigned drivers from loading, and it also helps to stop malicious software such as rootkits.
Okay, almost there. That one's done. Let's do this guy. Here he is again. I think he's okay. Let's see what he has to say. 3, 2, 1, skip. There we go. Hold on.
Says, if you can smash...
Okay. little longer this time, it's 5 minutes, then we'll take a break, come back to the labs, then we leave.
There's an old adage for computer novices that says, if you can smash something with a hammer, it's hardware. But if you can only swear at it in futility, it's software. But not everything is that cut and dried. And one of the most important parts of your PC is actually a closely linked fusion of hardware and software. I'm talking about the basic input-output system, or BIOS, which I certainly don't recommend hitting with a hammer, by the way, no matter how upset you are. So the BIOS is a very small piece of code that sits on a read-only or a flash memory chip on your computer's motherboard. It's often referred to as the motherboard's firmware, since it links the software to the hardware. But how? Well, think about it kind of like a person. Your brainstem helps control very fundamental bodily functions like breathing and your heartbeat, but it doesn't do any actual thinking. So your computer's BIOS does some very basic but crucial things without which you couldn't watch TechQuickie or have your Red Bull fueled CSGO marathons, but it doesn't, render graphics or anything like that. So when you first turn your computer on, the BIOS is the first thing to spring into action and wake up the rest of your computer, kind of like how your car's ignition gets the engine going. The BIOS first checks settings stored in a CMOS chip to determine how the user wants the system to run. So that's all that stuff that's in the utility that you get to by mashing delete or F2 when you first boot up. Then what it does is it initializes your devices accordingly: CPU, RAM, graphics card, peripherals, and so on. After this, the BIOS will run the power on self-test, or POST, to make sure that all of the gizmos inside your case are functioning correctly. If everything is hunky-dory, you'll usually hear a single beep to let you know that everything's good, provided that you installed the little speaker that came with your motherboard. If you get an error, like beep, 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 it's not Morse code, it's probably telling you need to reseat your RAM or a video card, or check for a part that's just plain gone kaput. Once that's done, the BIOS will check for a bootable device, meaning some kind of drive with an operating system on it, and then it'll hand off control of your computer to the OS. Now, old school BIOSes often provided a link between your keyboard, mouse, and other devices and the OS, while modern operating systems like newer versions of Windows control the hardware more directly. So once you're at the Windows desktop, your BIOS basically goes to sleep until you need it to start things up again. Seems pretty straightforward, right? Well, sort of actually. The way that the BIOS was implemented for a long time had some very serious limitations, one of the most obvious of them being drive support. The system that a conventional BIOS uses to access your hard drive or SSD, called the Master Boot Record, or MBR, could only handle partitions less than 2 terabytes. And that was fine for a long time, but with many modern hard drives holding way more data, it became obvious that something new was needed. The Unified Extensible Firmware Interface, or UEFI, which no one can agree how to pronounce, was born. Not only can UEFI deal with insanely large storage devices, we're talking millions of petabytes here, it's also quicker than a conventional BIOS to boot up, and can use an actual graphical interface, complete with animations and mouse support. Older BIOSes only featured that blue screen that looked kind of like a crash, but it was fine, which at least I guess was better than the really old days where there was no BIOS utility at all, and you had to physically move jumpers around on your motherboard in order to change settings. Speaking of going through tedious procedures in order to make basic changes to simple stuff, FreshBooks is the tool that makes your accounting
Shut
accurate.
up!
Send out whether you're a here.
Oh man, that just caught me.
Fine. What thing I speak? You can try TechQuickie.
Oh man, I'm
the
so
like
sorry.
button. It's more of a
I
sideways
got caught.
thumb.
Shut up. I might have to change you. You selling something. Okay. What do you feel about the BIOS UEFI? Do you understand it?
Yeah.
No, you don't. You do? Seriously? Okay, let's do this. Let's come back at 5 minutes and do the labs. And I gotta go. I'm tired of talking. So let's do labs when we come back.